Hey Simonics, what's up? Welcome to a new tutorial, and today we're going to make a bit different kind of tutorial because today is not about Ionic but about NestJS. I wanted to get into this since quite some time, and today we will build the first part of a second part tutorial. And the first part is about creating a NestJS API that allows us to upload image and to get all the uploaded images. So in the second part with the Ionic app, we will then create the app to actually upload the files we're using Capacitor on the web and on the device. But for that, we have to set up an API, and I wanted to give you a little NestJS tutorial since quite some time, and I hope you really enjoy it. Now, if you've never used NestJS before, you have to install the CLI first of all locally, and then just like with Ionic, you can get started and create a new project by running nest new, and I will call it image API. Now, within your folder, you have to install a few packages. The first one, TypeGoose, is a package that will help us to define the database entities. There are a lot of ORM tools out there, and I usually use a MongoDB database, so this one is pretty great. We also need the TypeGoose package, the actual Mongoose package, which will be used in the background by this package, and also the NestJS Platform Express package, because this will help us with the file upload. Finally, you can also install the types for Mongoose, and then we get into the creation of a few files. So with these commands, what we get is a new image folder with an image module, an image controller to define our endpoints, a service to perform all the queries to our database, and the actual image that we have to implement. All right. Once you get all of this, and of course, check out the code below the video if you just want to copy the commands, we can get started with the app module and actually remove the app service and the app controller, because this is just dummy stuff and we don't really need it at the moment. In order to fix the issues, we have to remove app service and app controller from here as well. And make sure your image module is imported, but usually that happens automatically. Now we can go ahead with the TypeGoose module, and you will notice a lot of similarities between Angular and Nest if you've never used Nest before. So for root, and then paste in your MongoDB URL. Mine is actually right now localhost, and actually the whole thing goes into our array of imports. And now, of course, no code completion today for Simon as usual. I really hate this. I don't know, sometimes it works and sometimes it's just not working, and that's kind of something I really don't know and don't like, but now it actually works. But anyway, this is the syntax that we need for our package, and I feel like I have too many brackets. Now it's fine. Now the import also looks fine. This is basically our initial connection to our database. Now let's define our image model. As I said, this is to write the files to our database, and I will call it, perhaps I will just call it API image, because that sounds a bit better. I guess will this break my imports? No, this is not used anywhere. So no problem. First of all, we should add a read-only property, because the ID is automatically generated once you use Mongoose. Ooh, interesting. And if you don't add the ID field in here, you will actually get some typing issues in your code later on. So simply add it from schema types object ID, that's the type for our read-only property. Then an image might have a name, and you usually just write it like this with Mongoose, but to make it work with TypeGoose, you simply add an annotation property, and I will say require true, so you can define a lot of things in this. And now we have a nice property that will be stored to our database, and we will repeat this pattern now as well for our image file. I will actually store the images as buffer files in the database. This is something you can do. This is actually okay, but it depends on how many images you want to store, how big these images are going to be. This is just a test example, and Also, it would work in cases where you don't have too many images. So for Facebook type of apps, of course, it wouldn't work. But for a lot of other apps, this is actually something that you can definitely do. But if you want to, we can have a discussion about this as well. For now, we will just go ahead. The default for the image file or the actual properties inside the image file will be a buffer and the content type. So we can later on deliver the right content type with the file back to the user. And for the default, I will set this both to null because we will see this once we create a new image, that we actually save it to the database first and then add the image. So it's just a tiny thing. I will get to this later as well. Now a date might make sense. Usually you pick the default now, and then we will call this created at date. And finally, a property that I don't want to store to the database, but that should be included, because when the user requests all the images, I don't want to transfer all these data buffers back to the user. And what we do instead is create a little URL to the image on the fly, like the server /image/image ID. And at that route, the user will actually get the real representation of an image, just like you request an image on the web. And this URL is something I don't want to store in the database, because I want to basically calculate it once the API runs somewhere. And therefore, I just add it to our API image class, so we can later set this and don't get any other TypeScript issues. Now we got this in place, and let's head over to our image module. We got the image controller, we got our image service, and now we got a few imports as well. So we once again need the TypeGoose module, and now we can call for feature, because we're going to tell TypeGoose about our actual database object. And we use a bit different syntax than the usual. Normally, I think you would just pass the API image somewhere in here. But I also wanted to set some schema options. This is MongoDB related. And what I want to do is I want to hide the version key. So from all the responses, you usually get ID, name, whatever, but oh, sweet Jesus. But also in those responses, there will be like a key like this, the version key. And I don't really want to have this in my responses. And I just wanted to show you it was something I definitely want to have. And there we go. It's easy as that with TypeGoose as well. Now, we'll make a little preparation for the image upload. If you've used Node.js in the past, you might know that Multer is usually used for image upload, and that's also the reason why we installed the Platform Express package from NestJS. It basically gives us access to the underlying Express platform that's, I think, used with NestJS in the background. Now, with a Multer module, we can register, we could simply register it. Or what I also wanted to show you is how to use a factory, so you can immediately add a little filtering to your upload. And I will bring this in because I really fear to type this. No, actually it's fine. So the image filter will filter the original name and check for JPEG, PNG, and if anything of this, or if it's not in there, we will return unsupported file type bad request. And now this filter goes straight to our file filter right here. And then once we apply the annotation for the file upload to an endpoint, it will always go through this image filter. So you can imagine and create your own little filters to filter really as well on the backend side. Usually you can do this on the front end as well. But it's always more secure if you add stuff like this on the backend side to really say, this is the wrong file, I'm not going to accept this. All right, let's go over to the service. It's really kind of like when we're building an Angular application, right? We construct with the app module, we set up the routing, then we go to the services and provide all the functionalities, and finally we go to the controller and view and implement everything. And that's basically the same like here, only that we don't have a view. But we got an image service, and into that image service we are now going to inject our API image, and that will be a private read-only image model. And actually, I'm not sure. Let me bring this in because I don't want to make a typo once again. The type is kind of strange. You can usually just go ahead and add all the missing imports somewhere. Inject model. Yeah, there we go. Everything in here. So this is now our connection to the database. Sometimes I think with Java it's called repository. And now we can go ahead and create all the functions. We're going to create a create function. We are going to have a find all. We are going to have a get by ID. ID, I can already add this. And then we also got remove image. So basically the standard CRUD operations that we want to apply. Now, in order to create an image, we must already think about the application and what the application is going to do. So the application is making a post request to our API, which includes a file and perhaps a body of data like name, perhaps any description, location, think of Instagram, all the things that you could add to an image. So we got a file, and then we gotta create image. Yeah, I just in this moment forgot definition type, doc type, data type, whatever this means. It's basically describing the element that we want to write to the database and the format the element needs to have. So this is what we're gonna pass, and it looks like I made a little typo here. There we go. And with this information, we can now create a new image by calling await this image model and pass in the object that we want to create in the database. Right now, it is not saved. We need to call new image .save before it is actually written to the database, and that's also what we're going to return in the end. Okay, yeah. It's of course we're creating a new instance of this object. Now, what we write to the database or what we create as an image model here has only the name and the image file. But actually we need to store this in a bit different way, and therefore we can use now the new image file, and then we can set the data and the content type. And the data is now the actual file.buffer. This comes from Malta. Let's also put a little lock here, my file, so we can see this a bit better, and perhaps also a console log, new image. And as I said, we want to save the data. We also want to set the content type, so file MIME type. Perhaps we should add some kind of typing in here, but well, let's leave it like this. Why do you complain? Yeah, I got a lot of ESLint errors, but that's fine. Should we finish this? Yeah, I think we should just quickly go through this, because all the three other operations are really just standard Mongoose stuff. To find all, simply use the connection to your collection in the database, call file, find basically anything. And I want to exclude the image file because, as I said in the beginning, in the list, I don't want to return all the buffer files. I can do this. Let's add this in the end, so then you will understand why we should pass this. To get an image by ID, simply call find by ID, and to delete it, simply call find by ID and delete. There we go. That's our service, and now we can head over to the controller to define the actual endpoints of the application. First of all, we need also a constructor which holds our image service. So that's really the usual setup of a NestJS API. You got the services, the model, and then the controller with the routes. Image service, there we go, and that's it. Now we can define with annotations the routes in our API. We also already have defined that this is image, which means we can access it right now at localhost/image. And if I would now call this one, let's say upload, it would be the route image/upload. So everything in this class is defined under the image namespace. And for our first post, we will actually use the standard image because we're adding an object to this collection. And what we add now as well is use where this is this coming from? Yeah, everything is coming from NestJS common in usual. So use interceptors, and please use the file interceptor and look for the key file. We haven't defined a function, so that's why it's still red. So let's add this as well and close it. And you see we got quite a lot of things that needs to be imported, but basically everything comes from NestJS common. We got the actual uploaded file, request, result, body, everything that we need. So now we can use our image service because we defined everything up front. Await this dot image service create. We pass in the file. Malter handles this already in the background. Perhaps we could or should also add a little log in here. Filter file, just to see in which order the different elements of our application are actually called. So this will now really write a file to the storage, to the MongoDB, set the data buffer for that object. And once we get this back, as I said, we want to, or perhaps let's for now let's return it. Just for the sake of seeing how everything looks, because we've done enough of typing already. Oh, 70 sweet Jesus, we need to hurry up. npm run start dev. I think that's the, let's take a quick look at the package JSON, because this already defines start dev, debug, prod, and also all the other commands, but we're going to start it in watch mode. So our app is starting, and I really hope I didn't make a mistake. Looks good. So here are the routes that are created in our application, and to test this out, I will bring up Postman and use a post to localhost/image. We see we can define a name. My name this is, and we can select a file. So let's add a little image and then hit upload. Okay. What we see is, first of all, let's take a look at the console log. The first log is from our filter. We already see field name file, original name, encoding, and MIME type. That's why we were able to use the MIME type as well. My file contains, again, all of this information, and the new image right there in the service. We have this log for the new image. It has, for the image file, still null values, I think. Actually, we could do this in the beginning. Maybe we could directly add the image, but it works this way as well. It's basically the same. So we can keep it like this. But now you see that we get all of this back. We get a buffer, and just for one image, it's really a huge response. And that's definitely not what we want to have in our front end. So in order to make this now a bit easier, we can first of all call image to object, because right now it's a mongoose or type goose object kind of thing, and we can't really set any properties on image. And what we want to do is we want to set on the new image the URL to something like whatever, devdactic.com. Of course not. But that wouldn't be possible if we are not calling to object on it first. So now we can go ahead with a few changes. First of all, we're getting the host. So I don't have to add localhost or the endpoint where it's deployed. We can simply get this from the request. Then I will set the image file to undefined because, as I said, image file shouldn't be in this response right here. And also I will set the URL now to something else. Let me quickly bring this in. And we're using string literals to calculate the values of host and the ID. And the result will now look a lot better. So let's do our post once again. And then we see that it's still the same. I think I also, no, that's here where I commented. I think I'm still returning the wrong object, right? Yeah, you could have told me this. It really makes me look like an idiot. Now let's do it again, and there we go. Okay, looks a lot better. Perhaps you could format this, Postman? No? Can you? It's not that hard to format. Perhaps he's still calculating the last value. So now we got created, ID, name, and a nice URL. Now we just need to make sure that at this URL we actually see something, and I think I just messed up Postman. Let him calculate. So what we want to implement now is, of course, the delete route. I will just bring this in because we need to hurry up a bit. Let's add all missing imports, delete by an ID, call our image service, remove image, and that's basically it. No other thing to do. We want to get the image by ID, and for this we can use a get request now and add ID in here so we can easily access it. And then I will bring this part in because this is something I don't want to type all the time. Maybe I need a snippet for this. So we can access the param ID quite easily with NestJS as well. And just like before, we're now calling get by ID using our ID, which gives us back the image. But we don't want to return the whole image object. We just want to return the image with the right content type and the buffer that is stored in that image. So perhaps I could also, I don't know if this is, yeah, let me see. There we go, my Robo3T. Here we can see the image file, data binary, and the content type. And this data is what we want to return with the right headers set, because this will enable us to simply return it like we're accessing an image. So we can call return resources sent image dot image file dot data dot buffer. And once we've implemented this, we're now able to use the actual result. I think that's actually from just a minute ago. So let's try this out. And there we see we get back this image, perhaps a bit big, but that's an issue for the front end, just by accessing the ID of the image. And now, as a final little piece of snippet, we also add the code to get all images. So a simple get to image with without anything else. This will give us all images, and for each image we now want to set the URL. And actually we got a nice code completion here because we got the type of the image. So if we wouldn't have added the URL as a property in here, we would now have a problem to actually set this URL. And I think, yeah, I think this was the place where I commented something else. So let's try. We make a get request to image, and we see we still get back the data. And that's why I added image file to our find command, because this will make sure that the image file property isn't actually available in the response. In the find all, it's really not interesting. We're just creating this using the image ID, and in that request we can use it. But in this overall request for a list, we don't want it. And now we got a really nice list creating of elements with ID, created at, name, and a URL to an image. And this is now something that our front end can definitely work with. We can show this list, we can call these endpoints and get the real images. Looks like I really messed up something. Perhaps I uploaded a wrong file, I don't know. but I'm sure we can work with this in the front end. And that's already the end of our NestJS API with image upload. I hope you enjoyed this kind of different tutorial, not Ionic today, but still feels a lot like Angular. If you haven't tried Nest, perhaps today is the time to get started with it. And if you want to see more on Nest in the future, just let me know below the video. I would be really happy to create more. And as well, make sure to come back in 2 weeks when we have the second part with Ionic for our image upload with NestJS, Ionic, and Capacitor. If you enjoyed this video, please hit the like button and stay subscribed so you get notified about all the new tutorials, quick wins, and other app development and web development videos on this channel. If you want to learn more about Ionic with in-depth courses, a community of like-minded developers so you can learn and build your apps faster, you should definitely check out the Ionic Academy, which is my code school to help you with everything Ionic, with a huge library of courses, material, and a supportive Slack channel so we can get your app out. I hope you enjoyed this video. I will see you inside the next video. Have a great day and happy coding. Simon.